We get to look at the thinking classroom today. This concept has been around for a little bit now, a couple of years. And looking back, perhaps it's one of the most fundamental shifts that we've had in teaching math in the last little bit. It's added so much to the way that we think about how to deliver mathematics curriculum. So the work on Thinking Classroom is based on the work of Peter Lilladal. He's a professor in British Columbia. Most of our schools should have a copy of his book already. If you don't, let me know. We'll make sure that we get a copy to you. There's a lot that goes into all of the work around a thinking classroom, and we don't have time to do it all today. Peter Lilladal does great presentations, and they take days to get through all of the material. I mean, he's got a whole book on this. We're going to try and summarize it in a 15 to 20 minute video. Fingers crossed. We'll see how it goes. But a couple things that we're going to try and really focus on: this idea of random groups, doing some work with vertical whiteboards, and of course the questioning, right? What questions are we going to actually ask? This is what I think is a terrific sketch note done by Laura Wheeler. She's a teacher out in Ottawa. Really does a good job of quickly summarizing the different components that we need for the thinking classroom. So we'll leave it up there just for you to get a bit of a look at. It's easy to find if you try Googling it. But it really summarizes a lot of these key ideas. We're gonna nail down on a few of them, but we don't have time to go into all of it. And some of them are easier than others. So one of the suggestions that Peter Lilladal makes is to start in certain places, the random groupings, the vertical spaces, of course, and gradually add in more characteristics as we go. It's very difficult to implement all of this all in one step. So here's the beginning of it, the idea of trying to do visibly random groups. So there's a couple pieces here. First off, just the random group idea. The idea there is we're trying to have lots of different kids having the opportunity to interact with lots of others. So different students will have the opportunity to share their knowledge of different things at different times. We're going to be able to play off the strengths of different students at different times. So that's going to be kind of nice. Making it visible is as simple as just using a deck of cards to make the random group. So we're really emphasizing the fact that this is what's happening. We're not hiding anything. We're intentionally making it random. And that would hopefully help the students to understand that, hey, each day you're going to work with someone new. This is just the format that we will always take. Shouldn't be any arguments, hopefully, if we do it that way. Pardon me. A couple of important parts. The fourth and fifth bullet there on the slide talks about number of students per group. So we're sort of aiming for that 2 to 3 students per group if possible. And I know that can be difficult depending on the size of your classroom and how many kids you might have in the classroom. But if you start getting a group that's too big, then you'll have students that'll maybe back away and not be part of the group. So we're really aiming for that, either 2 or 3 in an ideal world. And the one marker part is really significant because you'd often think, 3 kids in a group, make sure they each have their own marker. But Peter Lilladal suggests going the other way, just 1 marker per group. And the reason you do that is it forces the group to work together. So one student would be writing and the other group members are supporting that student, not off doing their own thing. So pretty good suggestion, I thought. The other suggestion he made was to have all of the students using the same color, whereas the teacher would have a different colored marker. So if the teacher comes around and makes some sort of a notation on the work that the students are doing, you'd be able to look back and know what you did compared to what the students had done. The other part is the vertical whiteboards. Now I'm saying whiteboards here. I like the whiteboards, but don't think it has to be. You can work on windows, chalkboards, of course, lots of different ways that you can write. The most important part is that it's vertical. There's a couple of reasons for that. Making it vertical makes it easy for other students to see what other groups are doing. So that's really helpful. It also makes it really easy for the teacher to see what other groups are doing. So it's going to allow us to know where I'm needed at a particular time, right? What group's struggling, which group is progressing really quickly through a particular problem. It helps me know what to do. It also helps to defront the classroom a little bit, right? I'm used to having my smartboard at the front. That's kind of the center of the room. This is helping to change that a little bit, to have it not just be the teacher delivering information from the front, but rather the knowledge is just happening everywhere. As students are completing tasks, they're learning. A lot of what can happen here is sort of twofold. You could have the vertical work be done as practice, for example, after a lesson, right? This is a good way to do some practice problems. This could also be done as a lesson, right? The kids could be up there right from the start and working on things right away and gradually learning what you want them to as they're doing the questions, rather than me always just doing examples at the front. Maybe I can have the students be doing the examples themselves. And that leads to what I think will be pretty significant for the new D-Stream class, which is the idea that we're going to be doing more small group instruction. So again, traditionally, a teacher would deliver a lesson and then we go from there. With the diversity that we're going to have in our classroom, having small groups at a given time might really be helpful because it's going to allow us to give really targeted instruction to a particular group at just the right time. So rather than delivering all of the information to everyone all at once, instead that information might be coming out much more gradually as we move around the classroom and support different groups at different paces. So I think that's something to keep in mind. One other thing here, it's having the kids up around the room that might start to help with some of our assessment pieces around observations and conversations. So, I mean, products are not hard from a math perspective, but we often see the students doing really good work at times like this. And that's an opportunity where you maybe can take advantage of some of those things you were seeing, some of those things you're hearing to help out with the assessment a little bit. This is possibly my favorite slide, this idea of trying to manage flow. And it's a really tough one, I think, too. But the point that Peter Liljedahl was making is that at any given time, if we were just teaching doing an example at the front of class, the level of that particular example is probably only correct for a few students in the class. For some, it's too easy. For some, it's too hard. It's only going to be a few that are in that sweet spot where that question is just the right level. So the idea here is trying to manage flow, which is trying to have the question level be right at the right spot for the kids so that they're engaged with it and ready to go. So he's created this this nice little diagram where we're balancing ability of the group versus the challenge of the question. And what you can imagine, I think, is if the ability level of the group isn't too strong yet, but the question is too hard, then we're in that frustration zone. Whereas the other way around, if the ability is really high, but the question is really easy and the question is boring, and again, not too much work gets done. So we're aiming for that sweet spot in the middle, which is what he calls the flow. What we're going to look at in the next couple of slides is ways that we can try and create questions that will help with that. So how do we keep groups in that flow where they're constantly progressing? And basically the idea is we want the students to be challenged just enough that they can figure things out. And then once they start to figure things out, we need to give them that little bit more so that we keep pushing them forwards each time. It's a tricky balance. We're going to look at two different types of question scenarios, I suppose. One is called rich tasks. And we've heard a lot about rich tasks, I think, in the last 5, 6, 7 years, probably even. Rich tasks are this idea of trying to give students a really good question, a meaningful question, something that's applicable to them, something that's open, something that is low floor, high ceiling. There's lots of components to a rich task. And honestly, because there's so many components to it, that makes it difficult. It's not easy to make up a rich task. It's very difficult to make up a rich task that specifically hits a curriculum topic that you're trying to teach on a particular day. So don't get me wrong, I think this is a particularly tricky one. I'm going to show you a couple here just to give you an idea of what we mean. But again, I don't mean to underscore this is difficult. This isn't easy to come up with these problems. This one's probably my favorite. I've used it forever and in lots of different examples and lots of different classes. The 4 fours problem, trying to come up with expressions using exactly 4 fours to create answers of 1 to 20. It's terrific for number sense. It's terrific for order of operations. But what's nice about it, again, is there's fairly low floor. You can get into it fairly easy. I could just add 4 fours together, right? That's one possibility. But crazy high ceiling, depending on where students want to go with this. We could start talking about fractions. You see fractions in there. You could start talking about square roots. You could start talking about factorials. You could start talking about decimals. There's lots of different things that you can do with this. So that's an example of a rich task that would be appropriate for, again, number sense, order of operations sort of thing. Here's another one. Found this off a website. I kind of liked it, though, having to do with volume of rectangular prisms. So you have 3 different rectangular prisms. The total volume is 80. What could the length, width, and height be? This one isn't quite as low floor, I don't think. It's a little bit harder to get into, but lots of extension possibilities, right? Once you've come up with one answer, can you come up with another one? Can you come up with one where one of the boxes is really small? Can you come up with an example where one of the boxes is a cube? Can you come up with an example where all of the boxes are a cube? What are the different things you can do with it? So lots of possibilities for extensions here. And here's one more. A couple slides ago, there was a quote from the Enrich website, which is a website out of England, I believe. And they're great. They have lots of good rich tasks there. I'll provide the link off to the side later. This is one of their examples. They're talking about a gutter, and this idea of just, can we design the gutter to hold as much water as possible? What sort of design should we take on it? And so we're looking at the cross-section as a way of trying to maximize the volume. But really in this question, we're going to be dealing with areas, right? Area of here a rectangle, and then we could change the design to make it a triangle. And they even suggest going into a circle. So different ideas, and again, just different extensions. That's rich tasks, and I think rich tasks are tricky. Here's the other one, and this is one that I have started really liking lately, but I don't have a good name for it. So the closest that I've found is people have been calling these math strings or number strings. But that seems to be a little bit more of an elementary concept because they tend to use it for learning arithmetic, learning addition and subtraction and multiplication and division, that sort of thing. And I want to use it for our high school concepts. So sometimes I've been calling them a question progression as well, which has a great ring to it. But it's this idea that we're just going to create a series of questions that we want students to progress through. And they're going to start from relatively easy and gradually build into extension level problems. This is an example that I really like by Michelle DeFilippi. She's a teacher in Toronto area. And it's a great example of a place to start with collecting like terms and gradually building. And it's only a starting point. There's more questions that would follow. But it's that idea of, if I give them the first question, get them thinking about it, how can that help then lead into question 2, lead into question 3, and so on. Here's another example that I made up. And this one has to do with volume again. And it's just volume of a rectangular prism. But what I want you to imagine, I'm going to show you a couple more questions here in a second. I've created about 10 to 12 different questions. And very intentionally, once you get far enough along, we're very much into the extension type problem. Here, take a look. These questions are getting quite a bit more difficult. The idea, though, when I create this is I have a goal in mind that I want the whole class, every group, every random group, to hopefully have gotten to, say, question 5 or question 6. That would be my goal. I want everyone to make it that far. And as long as everyone makes it that far, I'm feeling confident that we've done what we wanted to that day. We've completed our learning goal. That the expectation was to get that far. But it's really important that to manage the flow, we're going to recognize that different groups are going to be moving through these questions at different paces. So if I want to allow time for certain groups to possibly move more slowly through, I have to make sure that I have stuff for the other groups to do. So when the other groups are already through question 6 in the first 10 minutes, I need those extension questions, and that's what those are there for. So questions 7, 8, 9, 10, 11, 12, I am not expecting every group to get to those questions, but they're available for me so that I can provide that to the students that are ready for it. It's all about managing the flow, right? Trying to give students questions that they're ready for at the right time. Now, consolidation is big, right? It's probably the most important part of our whole lesson, really. Like, if we're not wrapping it up well, if we're not reaffirming the ideas, making sure that the point of the lesson is really sinking in, then we kind of miss the boat. It's also a really hard one because towards the end of the class, kids are ready to go, or maybe they're still busy working. You don't want to interrupt them. Teachers are sometimes tired. You're already thinking about the next class. I find this to be a particularly tricky part. But some things to think about. As you're trying to consolidate, it's a great idea to try and use some of the student work that would be up around the room. So you've got whiteboards that are there. You can make use of that. You can point out things that students have done. There's a book called The 5 Practices by Peg Smith. Terrific book. We've used it a few times with some of our projects at schools in the past few years. If you haven't had a chance to read it, it's a good one. Basically, it's just focusing on that idea of how do you organize group work. And the part that I like is the idea of summarizing. What do you do? And she suggests looking at different groups and thinking about the order that you need to share the information in. So which group had a good introductory idea? What group takes it a little bit further so you can really expand on things towards the end? It's a nice idea. The other thing that I want you to think about is as you're summarizing, don't feel like you need to have all groups share their work. Right? If you have 10 groups in the classroom, having all 10 groups share their work isn't helpful. And a lot of the time it might be the same answer. So you get to group 4 and they say, well, pretty much the same thing everyone else said already. It's okay to only have 1 or 2 groups summarize. It's also okay to not ask the kids. It's okay for you to do the summary. It's great if you can point to the kids' work and say, look what this group did, but feel free to talk about it yourself. That's okay. One of the things here talks about meaningful notes. So if we are using the thinking classroom as a lesson strategy, not a review, not practice, but we're delivering the lesson through this strategy, and again, small group instruction. The nice part about that is we're having the students doing the math, right? It's not them watching me do examples on the board and copying it into their notes. It's them doing it firsthand, which is fantastic. We really like that part. It means they're doing lots of math, but it isn't necessarily being recorded anywhere. So meaningful notes at the end is, hey, now we've already done a whole bunch of this math. Let's make sure that we've got some ideas summarized. But hopefully that doesn't take too much, right? They've done most of it. That was the good part. We just need to maybe write down a definition or two, maybe an example or two, put that in notes. So something to summarize at the end. The research is pretty compelling that Peter shares on his work. If you have the book, it's on page 60 of his book, where he goes into a little bit more details than the numbers you see here. And there's a lot here, so I'm not going to go into too much detail. I want you to, for a moment, just focus on line 2 and line 3, where it talks about time to task and first notation. And the research that he has here is comparing work using vertical non-permanent surfaces with other techniques. So, not standing, writing in a notebook, things on non-permanent surfaces. And again, what I want you to notice is those two, where it talks about time to task, how quickly kids jump into something, which is good. And the first notation in particular, that idea that how quick are students to actually start writing something down. And he really attributes that to the non-permanent part. So the fact that kids can write things down without having to worry about making mistakes. And we really want to encourage that, right? The idea that, hey, just get started. Right? Try something, see if it works out. If you need to change things up a little bit, you can. But I really like this, and it focuses on a few different things that students do well. The sharing of knowledge around the room works really well in this sort of method. So again, that sort of summarizes the idea of your thinking classroom. Lots of different components to it. If you have more questions, feel free to reach out and we can talk more about it. There's lots of pieces there. But as you're getting started, things to begin with are use good questions, rich tasks and number strings or math progressions, fantastic way to go. You want the visibly random groups, and you want those vertical non-permanent surfaces. If you can get those things in place, the rest of it kind of follows from there. All right, thanks so much. Hope that helped a little bit. Take care.